Your tutor again, and for this SPSS video we're going to be talking about linear relations, so going into scatter plots, correlation, matrices, and then also linear regression. So let's get started. So for these linear relations, there's a few ways that you can do this in SPSS. So the first way, if you want a visual of the correlation and then also of the regression line, for the relationship between two variables, you can go to SPSS and get the scatter plot specifically, so just the scatter plot. And then you can ask for a line of best fit. So that's the first thing that I'm going to do in today's video. So in SPSS, we need to go to our data set as we have here. Again, I'm just using the workers 200 file just for consistency. And like it says here in SPSS, in the SPSS instructions, you need to go to graphs and chart builder. And then now that you're here, you need to go down to scatter/dot and you drag the very first one in the list. The other ones, like, just ignore them. So you have this scatter plot, and then you need something on the X and Y axis. So let's say, for example, they ask you to maybe do like, let's say maybe they ask you for firm size on the x-axis, and they want to see how that affects the wage maybe of employees. So maybe the bigger a firm is, or the larger number of employees a firm has, maybe that means that the wage of the employees is higher or lower. We don't know for sure yet. So here we already have our x and y axes labeled with our variables, and the last thing that we need to do before we run this scatter plot is to go here where it says linear fit lines and click total. So when we do that, it's going to give us a line of best fit that matches with this scatter plot. So we want to make sure that this is checked. So once we have that, we click OK, and then we can see our scatter plot. So as you can see, pretty low relationship. But of course, we just need a visual. So here is how it looks like between the relationship of firm size and then also hourly gross wage. So now here we have our visual, and here we have our line of best fit. And so in the lesson, remember how I made this line of best fit actually show the equation. So the way I did that was, as you can see here, this little yellow box close to where my mouse is pointing, it says double click to activate. So we're going to double click on this, and you should get this pop up when you double click on it. So now that you're in chart editor, you need to click on this blue line so that it becomes outlined with pink. So once you click on this blue line once, then you can double click on it, and then it shows you this table. So you click once on the blue line to get the pink, and then you double click again in order to get this little section when it's talking about the fit line. So in this case, we don't need to change any of this stuff. All we need to do is just check here and say attach label to line. And so what that will do when we apply it and close this is it will give us the equation, the slope equation of this line. So here it says 12.37 plus 0.59 x. So this is the equation of this line of best fit. So now that we have this equation, we can just X out of here, and the new scatter plot will show the equation of this line. So that's one way that you can get the slope of the line, is just by running the scatter plot and then clicking on the line of best fit and putting the label on it like I just showed you. So here we see that the slope is 0.59. So that means that every increase in x by 1 unit, y will increase 0.59. So that is for the scatter plot. And the next thing that we should look at is correlation. So how do we make a correlation matrix? So obviously we have a visual here of how the two variables are correlated with each other, but we can also get this in terms of a table like I just said. So the steps to get a correlation table are right here in the slides, and then also we can follow this and get the correlation table ourselves. So here it says analyze, correlate. So we're going to analyze, correlate, and bivariate because we're just comparing two variables to each other. So again, let's stay consistent and pick wage and firm size. as our two variables that we're going to compare in terms of correlation. So we don't really need to change any of this stuff. The only thing that maybe you want to add in case the exam asks you for covariances, maybe it's good to check this box asking for cross-product deviations and covariances, because that will give you the covariance of the two variables with each other. So that's the only thing that you could maybe check off if you wanted to. If not, then, or if you don't think that covariance is going to be needed, or you need it later, you can always just run this again. It doesn't really matter. So you don't want to change any of this stuff, and so you just click OK, and this is your correlation table. So as you can see, we need to look at the Pearson correlation coefficient for the correlation between the two variables. So as you can see here, here are two ones, and that just means that the variable correlated with itself is equal to 1. So obviously hourly gross wage is going to be perfectly correlated with hourly gross wage because they're the exact same thing. But we need to look at either the top right corner or the bottom left box. And so this 0.161 is the correlation between firm size and hourly gross wage. So this 0.161 is our correlation of the two variables with each other, or the correlation of x and y. And again, if the exam asks you for covariance, all you would need to do is go down in the same box, either this top right one or this bottom left one. They're the exact same. And you just need to scroll down to where it says covariance, and you would see that the covariance of x and y, or the covariance between wage and firm size, is 4.560. So this is your covariance right here. So that's how you would get the correlation matrix with both just the regular Pearson correlations and then also the covariances. So this is how you would get this table in SPSS using the analyze, correlate, and bivariate function. So once you have this correlation table, the last linear relation that kind of fits in with this scatter plot that we ran previously is talking about linear regression. So what if you want to double check the slope of this scatter plot and actually run a linear regression to see this slope, see the constant, and then maybe find some more information about the variables. So in this case, you have linear regression, and you need to go to Analyze, Regression, Linear, choose your x and y variables, and then run it. So in this case, you can see the relationship between the two variables in the scatter plot, but what if we want it in terms of numbers? So in this case, we would go to Analyze, Regression, and Linear, because we're looking for the linear relationship. For our dependent, let's just put wage, and for our independent, let's put firm size. So in this case, we have these two variables for consistency, and under statistics, you can ask for anything you would like. Usually, I don't really mess with this one. You can ask for part and partial correlations if you wanted. You could ask for descriptives, like this would give you skewness, kurtosis, etc. You could ask for this type of stuff. I'm not going to. And under plots, you don't really need to look at this part, but maybe if you want a histogram, you could ask for a histogram if you wanted to. Again, these are just like a lot of options that you can click on for the regression analysis. But in this case, I'm just going to not change anything and just put in the two variables and click OK. So when you do so, you see all of this information. So model summary, ANOVA, and coefficients. So here you can see, if you look down in the coefficients table, you see that firm size has a 0.587 unstandardized beta. And all this means is that 0.587 is the slope of your line. And if we look in our scatter plot, here it says 0.59. So this one is slightly more specific by saying 0.587. So if in the exam they ask you for the slope and they ask for 3 decimal places, I would recommend running the regression analysis in order to get a more specific decimal. So 0.587. Rather than 0.59, but these are basically showing the exact same thing. This one is visual, and then this one is just in terms of numbers, because as you can see, the constant 12.369 is the exact same as what it says here, 12.37. It's just rounded up. So these represent the exact same thing, except obviously this coefficient table, you can't see the relationship visually with it, but with the scatter plot, you can. So they are kind of like two sides of the same coin, just using different SPSS processes to get here. But yeah, that's basically all you would need to know in terms of the regression analysis. So maybe running a scatter plot to look at correlation and regression, asking for the line of best fit. But then if you want to get more specific, again, you should run the regression analysis in order to get more decimals in terms of the constant and the actual slope of the line. So that's a way that you can actually look at this and see the relationship between two variables. And they'll tell you which two variables, obviously, to take the relationship of. But yeah, that's the main part of the regression analysis that you need to take a look at, except for just the R-square. So this R-square right here is 0.026, which means that 2.6% of the variance in wage is accounted for by firm size. So firm size accounts for 2.6% of the variability in hourly gross wage. So not too much for this example, but still it's good to know in case they ask you for something like that. But yeah, that's basically the main parts of the linear relations. Again, that is it for this video. Check out the SPSS playlist that I'm going to share with y'all for the rest of the SPSS videos, which are on their way right now. And I'll hopefully have them all updated by today. So thank you guys so much for watching. I hope this was helpful. And yeah, stay tuned for the next SPSS videos. All right, bye.